All right. I'd just like to welcome you to a conversation and some thoughts that we're going to speak about. Just the practicality and of hydraulics, you know, pneumatic systems, just using water pressure. And then, of course, going from using water pressure naturally, that's understanding that using steam power. In the same way, just you have different states of matter. And then when you can use efficiently one to the next. And really, without getting too wild, utilizing like the rubber tree or whatever. Um, and you think of things like gauges and seals. Gauge, that's what the title is. But an understanding like your O-rings and your seals and your connections, because when you're talking about these things, it's getting the pressure right and being able to gauge when you get down to it minutely. So like looking at the big and the small of what you can do with steam and the cascading in order to gain the hydro, which is in the water. People wonder, oh, water, right? When you think of power, where is there power? Well, we already like even understanding at a very easily to understand chemical level. Like, oh yeah, it has definitely has two carbon element. The water has it in it. Um, oh, can we get some power if we split the atom? It's like, well, the water molecule to get your hydrogen, and you can type it up like poorly, usually your Brown's gas or whatever. But I mean, spark. I think that's still a gas. You know what I mean? It's still an ignitable. Just stating that. And in the same way, copper's been used since ancient day, like even up in Michigan and the areas of, and people think, oh yeah, air are tools, and it's like, well, of course, but I mean, it transfers power quite like when you've got the water and you use that to spin the turbine, like just very elementary, just to review the elementary principles and to see how you can get the most efficient system, and then understanding that I really like the addition of the O-rings and the gauges and whatnot. But when we look at the older systems, in order to gain a picture at the newer, right? Because when you're looking at efficiencies, in order to getting in your tolerances, you're like when you're working towards the ideal of no waste and self-sufficient on its own. So when you're trying to work in the fourth dimension, let's remove time as much as we can. Meaning let's just do this right so that if we do it, time really shouldn't be a factor. And let's give ourselves a tolerance of, say, an age. Like, that should last for 1,000 years. Really? You know what I mean? Because if not, it's really not. But when you do get something, it's like this should last, and it should last for 1,000 years. All right, that's our standard. We do it, it should last for an age. And then you gauge it, that being part of your gauge. And all these things are gauged. Like the same thing with the wire. When you're like, oh hey, we're under copper, what can we do? It's like, well, when you get a wound like a wire, and like always working towards the ideal of efficiency. And like I was stating, if you're working the efficiency of the water in its pure form rather than being split and then gaining, rendering off the hydrogen and or your Brown's gas in order to gain your fuel. I mean, it's like, is there any way that we can, in order to gain our force, can we use just the water itself without splitting it? And it's like, yeah, we can do that as well. And someone's like, oh, is that more efficient or less efficient? It depends on what your ideal is and what you're working towards, obviously. The thing being, did we have the means to send water on an incline? then turn something and then have copper available, like just in order to just store power and then able to send it. You know, we want an idea of being Niagara Falls, sending it into Buffalo, and then like hundreds of kilometers or miles, whatever, away, being able to be sent down a hum, being able to be sent down a wire, buzz down a wire. That's why I mentioned wire a moment ago, and then it being being able to keep that hum, you know, or a vibration, if you want to look at it that way, you know, vibration. And it's like, how do you keep that vibration on? And it's like, well, if you can use magnets to keep its efficiency higher, and it's like, oh, okay, so if we use a magnetized tunnel, or you want to call it that, a magnetized tunnel, in order to keep the power generated within, so that you can even think of it yourself. You're like, oh yeah, I got to take one magnet, put it this way, take one magnet, put it that way, and then put that around the tunnel, and exactly, and all the power created in it is stored as it travels along the shaft. In the same way, working for current, it works for water. In the same way, it works for sound. And the same way that sound flows. So, like, we're going to, like, you know, oh, I want to get a little bit more of that. I get a little bit more like how the sound flows, because sound, you're like, hey, where do we have a flow? Where you have flow in water and you have flow in sound. You could set something up so that you could watch the direction of, say, a vibration as it leaves from sound to see where it's going to travel to set up your different efficiencies. In the same way, you can send water, and then by placing different things at different ends and then gauging your pressure at where those connections are as they move through, and engaging, and by doing that, placing your different hydraulic, your pressures at different places, working with, you know, and hopefully you've got some rubber. But that is what we are most certainly talking about. Listening to flow. stop the flow. Current, flow, vibration. It's the math I'm doing here on this here guitar. Open soft now, they can hear the call out. It's to my wonder wall. It's to my wonder wall. Hey, well, thank you very much. I tried to mix it in with a little bit of the lesson about water and hydraulics, and I think I'm gonna hopefully this can be heard for a moment. Oh, I started it off at the beginning again. I can probably find where it starts.
Counts. These explanations fail to account for the scale and I'll be the first to admit
I wanted to speak on hydraulic.
This idea sounds radical. It's buried arches and this documentary, because if the train stations of moved trains rather than merely support iron and glass vaults that appear to caffeine replaced counts. These explanations fail to account for the scale and sophistication of the systems that were already in place.
Systems.
Hydraulic lift mechanisms capable of moving entire carriages, water-powered turntables, and pressurized channels designed to distribute energy across vast concourses could not have been mere experimental curiosities. The water systems were too well engineered, too integrated, and too carefully maintained to have been decorative or secondary. And then there's the matter of intentional suppression across Europe.
Let's talk about that for a moment, this being educationally used, fair use and whatnot. The size of the systems and the scope, that's always what I've looked at. And then the availability, obviously, of the copper and how that mined and whatnot and so forth. And then, totally the distribution of power, and obviously through elevation, inclination, and not to get lost in the elementary subject, but then the vibration and the availability to send that down the line, how that's improved with the type of understanding that, if I had gold on this, it would be even more efficient at the distribution of the vibration, meaning it would keep its integrity, which is why I was stating, and I've gotten to it within the first 15 minutes, the magnetics around a tunnel turned once this way and once the other way in order to keep the magnetics with the power within, just like copper lined along a stretch, anything channel current will keep the power from degrading outside of that. People are like, oh, how could I keep power within using magnets, one way, one the other, and align it with that? There's little finites of math and things like that, but it's like the idea is how you keep it in integrity down on the line. Understanding the pickup that I use. Okay. The pickup is a magnet, another copper or a metal magnet set underneath here to pick up the vibrations. And the way that I'm playing is I'm not stopping, I'm letting the sound go. See, I'm letting the sound flow as I go. I'm not stopping it for anything. And now if I added my voice, and you've got to think of a rhyme, think of something that's true, that's rock and roll. Think of something, a statement that people can sit there and then you could dig into it like food, like a meal, because that is what man should not live by bread alone. You're giving them the word of God to eat. Like, so, okay, like you're taking that seriously. So when you're cooking, you're rocking it up, you're making that meal, and then you're taking that truth. So it's like you say something, you get a rhyme, and you say something that's true because people are going to remember that more. It puts it in the mind, and then people like repeating it themselves because if it's true, it's probably also beautiful because it defeats a lie. And a lot of people like to try to steal from you. And first they got to bind you. And what they use to bind you is usually half truths, mistruths. You know what I'm saying? Heck, they could even use something 99% true, but then that other 1%. Because the thing is, it might not but over time, exactly, but not the latent or the latent. It's like what's going to happen over time. The latency, meaning the delay, the delayed effect of buildup or combination, like an interest, the delayed combination. Now, that can also be done with vibration. 1, 2. The sound gets stronger, the stream gets thicker.
Early photographs show stations being
Flow.
altered, lower floors being sealed, arches removed, and underground chambers filled with concrete or rubble. Renovation records provide sanitized explanations like flood prevention or modernization, but these rationales make no practical sense when you look at the engineering. You don't seal off a functional hydraulic system under the guise of flood control. You destroy knowledge. The destruction and alteration appear systematic. They strip the buildings of their elegance, remove their original functionality, and leave behind a version of the station that looks industrially primitive compared to what existed before. This is where the Tartaria theory comes in. According to alternative researchers and enthusiasts, these stations were not purely Victorian inventions, but inheritors of an older civilization with knowledge of hydraulics, resonance, and energy systems that we may never fully understand. The widespread erasure and deliberate downgrading of the buildings makes sense in that context. An advanced network of water-powered stations capable of transporting people, energy, and perhaps even information across entire cities would be far too powerful and independent to allow control by later governments or industrial interests. The consequences of revealing such a system would have been technological tradition far more advanced than we are typically told. As I continued to study photographs from the 1800s, it became clear that these weren't isolated anomalies. Stations across London, Paris, and Antwerp all shared these traits. In many cases, workers and engineers at the time documented hydraulic mechanisms that are now forgotten or reinterpreted in modern literature. Many of these systems vanished almost overnight during the early 20th century, and the knowledge required to reproduce them was either lost or deliberately suppressed. There are even whispers of engineering manuals written at the time that described how entire urban grids could be powered by flowing water,
city streets,
manuals that no
paved
longer
with
exist
gold,
in
gold in the
public
water, like I spoke of before.
This
You put it on the
consistent
thing, and the
direction
vibration
was
goes more.
intentional or
The
otherwise,
gauge,
and it is not merely technical.
the gauge of the wire, like we spoke of before. The gauge of the wire that we spoke of before, that affects the vibration that comes through your door.
Show train stations with soaring glass domes, elaborate ironwork, and lower levels accessible via grand
There's like the verb in me and the
staircases
verb in you,
to
with the
subterranean
VIP that I'm
water
sending to you.
By the 1910s and 1920s, these same stations are
Very
flattened
good in the cows,
and
they
shown
the one is running cows and
It seems someone deliberately wanted to remove the memory of what existed, making future generations believe that technology and architecture had progressed linearly from primitive to advanced, rather than erasing the evidence of an older, more sophisticated reality. One cannot ignore the possibility that these stations were intended as part of a broader network, perhaps spanning continents, connecting cities with energy-efficient, water-powered transit systems. This network would have required meticulous engineering, extensive manpower, and a level of coordination that seems almost impossible for the 19th century, unless, as the Tartaria hypothesis suggests, it was inherited from a prior civilization with knowledge lost to modern history. And so, the final conclusion emerges from this research. The train stations of the 1800s, particularly those grand edifices like St. Pancras, Gare du Nord, and Antwerp Central, are more than historical curiosities.
My father sent me to the end of the world. Bring you back home if you can.
Water-powered engineering tradition that has been deliberately erased. Their arches, domes, and subterranean waterworks tell a story of ingenuity, power, and secrecy.
I'm gonna reach the angels at the end of the age, like before.
Reliable and integrated into the very fabric of the station, at the end of the age, alterations, sealing lower levels, removing machinery, and flattening architectural grandeur appear to have been intentional, perhaps to suppress knowledge of the energy systems and the sophistication of the civilizations that created or maintained them. By piecing together the photographic evidence, blueprints, and first-hand accounts, one sees a narrative of deliberate obfuscation and erasure. The once grand water-powered stations were systematically made to appear primitive, aligning public perception with the idea that steam and electricity were the only feasible power sources. But when the critical eye turns wonder, these stations were relics of an advanced system of hydraulic engineering.
Just a wonder of a soul.
Into a lost world that may have been Tartarian in origin. In closing, this episode reveals that what we see today is only a shadow of what existed, and the full story of these train stations, their hydraulic marvels, their architectural
Together now.
global water-powered network has been hidden
Alone with my empty cell.
time when human engineering was far more sophisticated than we typically tend to believe, and these magnificent stations, buried and altered as they are, remain the final monuments of a technology and understanding that modern society has been denied. The story of water-powered train stations is not just about transportation, it's about lost knowledge, deliberate suppression, and a tantalizing possibility. We are only beginning to uncover the truth. Episode 3 of the train stations of Tartaria that were powered by water dives straight into what I consider the crown jewel of 19th century railway architecture. St Pancras Station in London opened in 1868 and often referred to as the Railway Cathedral. As I began to research this structure, I quickly realized that nothing in the modern world even remotely approaches the audacity, scale, and elegance of what the Victorian engineers and architects achieved, or perhaps inherited, at this site. St Pancras wasn't just a station, it was a monument, a grandiose blend of Gothic revival architecture and what I would argue is Tartarian engineering at its peak, carefully disguised beneath layers of brick, iron, and glass. Walking into the station, even today, the vaulted ceilings, the soaring arches, the intricate ironwork, and the immense red brick facade give the unmistakable impression that you're entering a sacred space rather than a hub of locomotives. But what I wanted to understand wasn't merely the aesthetics, it was the technology and systems embedded within, most of which have been removed, destroyed, or deliberately hidden from public view. The most fascinating element, and the piece that drew me deeper into my research, is the role of water in powering the station. When you study photographs and blueprints from the 1860s, you start to see channels, sluices, and underground vaults that have no clear explanation in the official narrative. Official histories claim these were merely pumping systems or flood mitigation, but the scale and design suggest something far more sophisticated. Beneath the vaulted station, flowing water appears to have been harnessed to operate hydraulic lifts, turntables, and even early mechanical switches. There are detailed accounts in engineering journals of the period, now largely forgotten or rewritten, that describe a network of pressurized water conduits capable of moving entire train carriages across turntables using only hydraulic pressure. It's almost laughable to the modern engineer, trained only in electricity and combustion engines, to think that water alone could do so much, yet the evidence is there in the engravings and detailed blueprints. I spent weeks poring over the photographs of the original construction. You can see the arches descending to the lower levels, where street heights, brick channels carry water from nearby reservoirs. These channels water flowing current, which is powered from large aquifers, regulated the flow. Places where we place water. Official narrative, these were redundant safety measures for steam engines. That explanation makes no sense when you consider that the channels and valves predate much of the locomotive equipment,
Valves.
and they are proportioned to move weight far
Valves.
beyond what a simple
Better than the
steam
body.
safety system would require. When I began to read the first-hand accounts of construction workers and engineers, the
Gages.
letters and reports that escaped official
Valves.
rewriting, the picture
Gages.
became even stranger.
Valves.
One document from an engineer
And
named
gauges.
Joseph Cubitt mentions
Over
that water
the
pressure from the
ages.
reservoirs beneath the city
Valves
was capable of
and
lifting carriage
gauges.
without the use of
Over
bracers or
the
steam. He goes on to
ages.
describe a network of siphons and conduits that could deliver energy to different areas of the station simultaneously. This wasn't just decoration or safety redundancy. This was a deliberate, functioning power grid. And then there's the architecture itself.
And dreams that never fall.
Why were the arches so vast? Victorian architects loved grandeur. But I started to consider another possibility. That the geometry of the arches, the placement of the iron ribs, and the spacing of the vaults were all tuned to amplify resonance. Water moving under pressure creates vibrations, and these vibrations, if properly channeled, can transmit energy in ways that are lost to modern engineering, but may have been understood in a Tartarian context. The thought that these arches were just
such an old-fashioned
energy system is supported by the sheer scale
value. Love dares you to care about the people under pressure.
Decades to excavate. Photographs from the 1870s show these
Under pressure.
partially in use, with channels directing water
Under
toward
pressure.
machinery that lifts carriages and operates switches. It's almost impossible to imagine how this could have been achieved without some prior knowledge of hydraulics far beyond the accepted standards of the era. Then there's the issue of disappearance and cover-up. By the early 20th century, much of the hydraulic system had been sealed, filled in, buried in concrete. Renovations cited flood control as the reason. Yet again, the scale of these closures is extreme. Entire lower sections, some larger than the main concourse, were walled off. Windows and arches.
All right. Well, we've had a half an hour of fun.
Structural supports and possibly as energy.
I'd like to
moved or obscured.
Shout out Hidden Rabbit 3.
Steam engines were supposedly more efficient.
Really enjoying how they've placed together. So to go check that out.
But if water could lift entire
I think Hidden Rabbit 3 is doing a very good job of presenting the information in a well-packaged form. And I really enjoy that he is, I suppose, echoing some of the thoughts that I have thought that are way more plausible, Occam's razor or anything else, but definitely working with the steam and the hydraulics and the pressures and whatnot. And I think we are in the right direction. Excellent. Well, thank you for this very enjoyable time with me looking at vibration and gauge. And it's a small conversation that I think is very important. If you spend the time with me, right on, man. Okay, have a good day, everybody.
An orchestrated effort to hide evidence of an advanced civilization capable of harnessing